Hello. In this video, we are going to begin graphing absolute value functions. So, to begin, we must first determine what does an absolute value function look like. Our parent function is y equals the absolute value of x. There is nothing being added, subtracted, multiplied, or divided to this function. Therefore, it is our most basic function, which is why we refer to it as our parent function. We need to create a table of values so that we can determine what the graph looks like. If we take the absolute value of 2, it is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Because remember, absolute value is your distance from 0. We can't take a negative amount of steps, so none of our absolute values should ever be negative. They will always be positive. Let's begin graphing. To graph this, we know that our tables all translate to ordered pairs. So we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Let's begin graphing. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. We're going to connect these with lines and it's going to make a V. So you can remember anytime that you see an absolute value function, the shape of our graph is going to be a V. Just like the word value begins with V, our graphs are V's. Now, down here at the bottom I've circled a point. We refer to this as our vertex. Not every time will we create a table of values to graph functions because that can become quite time consuming. So you need to know the significance of the vertex so that you can graph functions more efficiently. So the vertex is our turning point in this case. Now, the more efficient way to graph, which I was referring to, is known as translations. Sometimes we'll have something added to the outside of our function. When something is added to the outside, our graph will move up. When something is subtracted from the outside, our graph is going to move down. So in this case, for absolute value functions, a number would be added or subtracted on the outside of the absolute value bars. Next, when something is subtracted on the inside of the function, it's going to move right. And when something's added to the inside of the function, it's going to move left. So in this case, when we say the inside of the function, we're referring to the inside of the absolute value bars. Now, when we're multiplied by a negative in the front of the function, our function is going to reflect across the x-axis. When something is multiplied by a negative on the inside of the function, we're going to flip over the y-axis. If we multiply by a number that is larger than 1, it is going to stretch it vertically, meaning our graph is going to get thinner, skinnier. So if our V begins like this and we multiply by 2 or 6, our graph is going to get skinnier, right? Instead of being out here, it's going to be a skinnier graph. If we multiply by a number that's in between 0 and 1, so a fraction such as 1/2 or 3/4, our graph is going to stretch horizontally. So instead of our function starting here, now our function is going to stretch horizontally, meaning it is going to get wider. So let's look at what all this means. We're going to graph an absolute value function using our translations. We have the absolute value of x minus 2 plus 4. We have minus 2. It's inside the absolute value bars, therefore it's on the inside of the function, meaning it moves right. We have plus 4 on the outside of the function. It moves up. So here we have a graph. We're going to use the translation right to up 4 to graph our vertex. Our vertex on our parent function began at 0, 0 at the origin. That's where it's going to begin here. So now it's time to move right to up 4. Now, we need to get the rest of our points, right? We need to be able to continue to establish this shape. Well, there's an understood 1 in front of our absolute value bar. That can be treated as our slope. So from our vertex, we are going to go up 1 to the right 1, and then we're going to go up 1 to the right 1 again. But we noticed in our parent function that our graph was symmetrical to the vertex. So we also need to go up 1 to the left 1 and up 1 to the left 1, connecting all of these points. Now, I'm going to show you another method to graph the same problem, but this is just another method to give you another option. So we know minus 2 on the inside absolute value is still going to go right 2, and plus 4 on the outside is still going to go up 4. And we understand that there's a 1 in the front. let's go ahead and put our parent function on the graph. Now we are going to shift this function all at one time. Right 2, up 4. Same answer as the previous slide, just a different technique. Let's do another problem. We're going to graph the absolute value function 2 times the absolute value of x plus 1 minus 2. We have plus 1 on the inside of the absolute value bars, so we're moving left 1. Minus 2 on the outside of the absolute value bar, so we're moving down 1. So now, here's our parent function. We're going to move left 1, down 2. But what part of our function have we not addressed? The slope of 2. So instead of going up 1 to the right 1 and up 1 to the left 1, we need to go up 2 to the right 1, up 2 to the right 1. And with this being symmetrical to the vertex, we also need to go up 2 to the left 1 and one more time, up 2 to the left 1. Connecting all of these points, now we see that our graph is skinnier than our parent function because we had a number multiplied in the front that was greater than 1. This function stretched vertically. Now we have one more problem. And once again, we're going to graph the absolute value function, but you're going to try it yourself. F of x equals negative 1 times the absolute value of x plus 3 minus 6. There's the graph. At least, even if you don't graph it, at least determine the translations. You have 30 seconds. Begin now. Okay, that was 30 seconds. Let's begin determining our translations. We have a plus 3 on the inside, meaning we are moving left 3. A minus 6 on the outside, meaning we are moving down 6. So here's our parent function. We're going to move it left 3, down 6. Now, we have a negative 1 out front, so now our graph has flipped down. So let's take away the parent function, and here is our function f of x equals negative 1 times the absolute value of x plus 6 minus 3. In our next video, we're going to continue graphing absolute value functions, except instead of them being functions, we are going to make them inequalities. So tune in for our next video. See you soon.